My name is P. Ramadevi, lecturer in ECE, and my subject is microwave communication and television. And today's topic is what is resistance, capacitance, inductance, and types of transmission line. So first of all, we have to know about what is a transmission line. So in the field of electronics, it is needed to guide the electrical energy from one point to another point. That means in order to transmit some electrical energy from one point to another, we require a guided medium. So whenever it is going to be requiring some signal from transmitting from transmitter to the antenna, we are going to be using a guided media calling as transmission line. That means which will be transmitting the RF signals from the transmitter to the antenna with least power losses. So that means whenever we are transmitting some RF signals from the transmitter to antenna, we require a guided media, and that is nothing but an transmission line. And whenever we are using this, which will be providing the lowest power loss. That means there is a smaller power loss is going to be done. Okay, so for that we are going to be using this transmission media. Okay, so in this session I am going to say that is the introduction to our transmission media and transmission lines, and what is the capacitance of a transmission line, and what is the inductance of a transmission line, and what is the resistance of a transmission line, and what is the leakage current of transmission line. Okay, so this is about this session, and the first one is how it looks. What are the transmission lines and how it looks means these are the best example. Why? Because whenever we see around the highways, we can see with this lines. Okay, these are the transmission lines which are going to be guiding the RF signals from the transmitter to the antenna. Okay, so these are the transmission lines. Okay, so whenever we are having the transmission lines, the loss of power while guiding the RF signals will depends upon the physical and electrical characteristics of the transmission line. That means whenever I have said that the loss is going to be very less in our transmission line, and the loss of power is going to be guiding the RF signals, which will be depends upon some parameters. That means that are physical and electrical characteristics of an transmission line. So what are the physical characteristics means? That includes the length, area of cross section, number of conductors. Okay, so like this we can calling as an physical characteristics, whereas electrical characteristics is nothing but an resistance, inductance, capacitance and conductance along the line. These are the characteristics which will be having the power of loss. Okay, that means whenever we are carrying some RF signals, so in that we are going to be getting some depends upon the physical and electrical characteristics. Okay, that loss is going to be depends upon the physical and electrical characteristics. So what are the physical characteristics means? That will be having as length, area of cross sections, number of conductors. Okay, and whenever we are having the electrical characteristics, they are resistance, inductance, capacitance and conductance along the line. So these are the special characteristics which will be having some power of loss while carrying the RF signals. Okay, so these are the transmission lines. And whenever we are having the traditional transmission lines which are at high microwave frequency cannot be used. Okay, that means the traditional transmission lines at microwave frequency is not going to be used in this. Hence, for that we are having another special types of guided medias. Okay, such as waveguides. That means I have already said that for any application for high frequency ranges, normal amplifiers and general oscillators are not going to be used. Specially it is going to be designed to use that. So like that only, whenever we are using the traditional transmission lines at high frequency ranges is not going to be used. For that we are using a special types of guided medias such as waveguides. Okay, so the waveguides are going to be used to transmit the microwave signals from one point to another point with a less power loss. Okay, so in this we can say that the waveguide is nothing but a transmission line which will be used at high microwave frequencies. Okay, these are transmission lines in our microwave frequencies. That means a transmission line is a device which is going to be designed to guide the electrical energy from one point to another point. For example, to transfer the output RF energy of a transmitter to an antenna, this energy will not travel through a normal electrical wire. Okay, although the antenna can be connected directly to the transmitter, the antenna is usually located at some distance away from the transmitter. So on board, that is, the transmitter is located inside a radio room. That means whenever we see the transmitter, it is not going to be placed on the terrace of the wall or the terrace of the building. Why? Because it is basically it is located inside a room. Okay, that is going to be calling as radio room, and it is associated with the antenna which is mounted on the mast, that is on the terrace. Okay, so for that a transmission line is going to be used to connect the transmitter and the antenna. So like this, the transmission line is going to be used to connect the transmitter and antenna. Okay, how it looks means it is nothing but a transmission line, okay, which will be transmitting the dots are going to be using as energies, that is signals which are going to be continuously passing towards the transmitter. Okay, so antenna, from the antenna it is going to be transmitting to the transmitter. Okay, so like this, it is an example. So what is a capacitance? What is a capacitance in our transmission line? So whenever we are calling a capacitance, first of all we have to know about that is a transmission line which consisting of inductance, capacitance, conductance, okay, resistance. Okay, all of the parameters are going to be there within the transmission lines. Okay, so whenever we are placing a transmission line which consisting of these electrical parameters under the transmission lines. So what is the capacitance means? How the capacitance is going to be done means it is defined as a shunt capacitance between the two wires per unit length. Okay, so whenever we are having the capacitance, already I have said that whenever we are placing a two plates which are placed in a parallel connection, so that will be having a capacitance. Like that, in the transmission line also we consisting of capacitance per unit length, which can be given as farad per kilometer. Okay, so the capacitance in a transmission line is going to be results due to the potential difference between the conductors. Okay, so in our transmission line, how it is going to be getting means it is nothing but an potential difference between the conductors. Okay, the conductors will be get charged in the same way as the parallel plates of a capacitor done. That means I have said that whenever the two lines are going to be placed in a parallel which consisting of a capacitance. Okay, so like that the conductors will get charged in the same way as the parallel plates of a capacitor. So whenever we are calling as a capacitance, the capacitance between the two parallel conductors which will be depends upon the size and spacing between the conductors. That means the capacitance which will be between the two parallel conductors which will depends upon the size, at the same time spacing between the conductors, same as that of a capacitor, of a general capacitor. Okay, so same as that. And usually the capacitance is going to be neglected for the transmission lines that are less than the 50 miles, it is 80 kilometers long. So whenever we are calling as a capacitance, the capacitance is going to be neglected for the transmission lines which are that is having the long, that is 80 kilometers. In the miles we can say that is less than the 50 miles. Okay, so however the capacitance will be making a significant for longer lines with a higher voltages. So For that we have to know about the capacitance also. Okay, that is the capacitance of a transmission line. So how it looks means, this is an example. So one line is going to be placed at the upwards and the other line is going to be placed at downwards. Between these two lines we are having some capacitance, so that is going to be drawn as capacitor symbols like this. So this is an capacitance, this is a one line and this is a one line, this is an infinite line. Okay, for that we are having the capacitance. Okay, like this. Whenever we are having some switch between the lines, we are having some voltages. Why? Because it is having some capacitance, means there is a voltage between that whenever we pass some signal. Okay, so like that we are going to be having capacitance of a transmission line. And the next one is inductance of a transmission line. So what is an inductance means? It is defined as the loop inductance per unit length of line. It is defined as the loop inductance per unit length of line. It is the sum of inductance of both wires for unit line length. Okay, which can be given as henries per kilometer. Okay, so in the medium and longer transmission lines, the inductance is going to be more effective than resistance. Okay, the current flow in the transmission line interacts with the other parameter, that is calling as inductance. So when the current flows within the conductor, the magnetic flux is going to be set up. Okay, so whenever it is having some magnetic flux, that will be calling as an inductor. Okay, inductance. With the variation of the current in the conductor, the number of lines of flux is also going to be changes. That means with the variation of current in the conductor, the lines are going to be changes. And whenever we are changing some lines of flux, and an EMF is going to be induced in that. Okay, we have known with the Faraday's laws that whenever we carry a current carrying conductor, whenever we are passing some current carrying conductor of a rod, we are going to be getting some flux is going to be generated around that rod. Okay, so that means whenever the hand is going to be touched with the current carrying conductor, the current is going to be flowing, and in that we are going to be getting some flux by saying with the Faraday's law. Okay, this induced EMF can be represented by the parameter calling as inductance. Okay, how it look means, you can see within the figure that whenever we are having a long transmission line, in that we are going to be getting some flux. Okay, why? Because whenever it is going to be having the flux, that flux is going to be nothing but an inductor. Okay, so you can see the coils in this. These are nothing but an coils, and it is going to be getting some magnetic flux around this. Okay, so whenever we are changing some variation in the current flowing in the conductors, the number of lines of flux are also going to be changes. Okay, this is because of the Faraday's law. That means the inductance is going to be defined as the loop inductance per unit length. Okay, it is a sum of inductance of both wires for unit line length. So it can be given as henries per kilometers. Okay, that is an inductance. So the capacitance of a transmission line, which will result to the due to the potential difference between the conductors, and the conductors gets charged in the same way as the parallel plates of a capacitor. The capacitance between the two parallel conductors, which will be depends upon the size and the spacing between the conductors. Usually the capacitance is going to be neglected for the transmission lines that are less than the 50 miles, that is 80 kilometers long. Okay, so that it is very important, that is the capacitance will be making significant for longer lines with a higher voltages. So like that it is going to be mainly we are going to be seen with the capacitance. And the next one is resistance of a transmission line. So that is R equals to rho L by A. We have well known about this. Okay, in a single phase or a two-wire DC line, the total resistance known as a slope resistance is equal to the double the resistance of either conductor. Okay, so that means in the single phase or in a 2-wire DC line, the total resistance is going to be equal to the double the resistance of either conductor. Okay, so initially the resistance is defined as the loop resistance per unit length of line, that is going to be given as sum of resistance of both wires for unit line length, and it can be given as ohms per kilometer. Okay, so this is about the resistance. Okay, so in a case of a 3-phase transmission line, the resistance per phase is going to be the resistance of one conductor. In a single phase it is different, and in the 3-phase it is going to be different. In a single phase, the total resistance is going to be equal to the double the resistance of either conductor, but in the case of 3-phase, the resistance per phase is the resistance of one conductor. That is going to be difference between the single phase and 3-phase. And what is a leakage current? Whenever we are using the transmission line, the air will be acting as a dielectric material between the conductors, and when the alternating voltage applies in a conductor, some current flow in the dielectric medium. Because of that dielectric imperfections, such current is going to be calling as leakage current. Okay, so whenever we are having the transmission line, in that the air will be acting as a dielectric medium or dielectric material. Okay, and whenever we are passing some voltage across that, some current flows in the dielectric medium. So because of that dielectric medium imperfection, that means it is not having the perfection of that dielectric material, and some current is going to be flowing, such current is going to be calling as leakage current. Okay, so this leakage current depends on the atmospheric conditions. Okay, which will depends upon the atmospheric conditions, and atmospheric conditions is not only that, and it will depends upon the pollutions like moisture and surface deposits also. Okay, so these are the leakage current, okay, between the transmission line, or which can be having some coming with the transmission line. Whether we are having the transmission line, that is, I have said that what is the transmission line means. In our electronics, it is needed to guide the electrical energy from one point to another point. So one form of energy is going to be passing towards the one point to the another point. So it is required to guide that RF signal from the transmitter to the antenna. So for that we are going to be calling as transmission line. So that means the transmission line will be guide the RF signals from the transmitter to the antenna with the least possible power loss. Okay, so the loss of power while guiding the RF signals, which will depends upon the special physical and the electrical characteristics of transmission line. Okay, the physical characteristics means which will be including the length, area of cross section, number of conductors. Okay, so like this we are having number of parameters under the physical characteristics, and under the electrical characteristics we are having the resistance, inductance, capacitance and conductance along the line. So these are physical and electrical characteristics which will depends upon the power loss. Okay, so when we are having the types of transmission lines, under that we are having the number of types of transmission lines, and the first introduced is going to be parallel transmission line. Okay, this can be calling as 2-wire open line also. Okay, the first type, and the second one is twisted pair transmission line, and the third one is coaxial cable, and the fourth one is waveguides, and the fifth one is fiber optic cables. These are the types of transmission lines. So we have a look about this introduction to the transmission line, and capacitance of transmission line, inductance of transmission line, resistance of transmission line, leakage current of transmission line, and the last one is types of transmission line. Let us have a quiz. The leakage current in the transmission lines is referred to as the A. Resistance, B. Radiation, C. Conductance, and D is polarization. That means the leakage current in the transmission lines is referred to as the option A is resistance, the option B is radiation, and the option C is conductance, and the last option is polarization. So what is an correct option? Please note this question. The leakage current in the transmission lines is referred to as. That means what is the leakage current? First of all, we have to know about that. So what is the leakage current means? Whenever we are using the transmission lines, because of the atmosphere effects, we are having a changes in the current. That means whenever we are using the transmission lines, in that the air will be acting as a dielectric material or dielectric medium. So because of that dielectric medium, so whenever the changes in the voltages are, whenever there is a change in the atmosphere effects, that will be effects on the dielectric medium. So because of the dielectric medium, there is a small current that is affecting by the dielectric material, calling as leakage current. Okay, so the leakage current in the transmission lines is referred to as. So what is calling as? The first one is resistance, the second one is radiation, and third one is conductance, and the fourth option is polarization. So what is an answer means? That is conductance. Okay, so that is the correct answer. And next, which of the following parameters is not a primary parameter? Which of the following parameters is not a primary parameter? So first option is resistance, second option is attenuation constant, and the third is capacitance, and the fourth one is conductance. So what is an correct answer? So please note this question. Which of the following parameters is not a primary parameter? Okay, the first one is resistance, and the second one is attenuation constant, and the third one is capacitance, and the fourth one is conductance. So the answer is B, that is attenuation constant. The primary parameters which are under the transmission lines are going to be resistance, inductance, capacitance, and conductance. Okay, so the attenuation phase and propagation constant are going to be calling as secondary parameters. So the odd one is attenuation constant. This is the correct answer. That means the following parameters resistance, capacitance, conductance comes under the primary parameters, and when we are having the phase, attenuation, propagation constant comes under the secondary parameters. Okay, this is about the transmission line. And next question is, the networks in which RLC parameters are individually concentrated or lumped at discrete points in the circuit are going to be calling as. That means the networks in which the RLC parameters are individually concentrated or lumped at discrete points in the circuit are going to be calling as. The first option is lumped, and the second option is distributed, and third option is parallel, and the fourth option is paired. So which one is the correct answer? So please note this question. The networks in which RLC parameters are individually concentrated or lumped at discrete points in the circuit are going to be calling as. The first option is lump, and the second option is distributed, and the third option is parallel, and the fourth option is paired. So which one is the correct answer? That is lumped is the correct answer. Okay, so whenever in our networks the RLC parameters are individually concentrated or lumped at discrete points in the circuit are going to be calling as lumped networks. These networks can be identified definitely as representing a particular parameter. As an example is the filters. Okay, so all of these are going to be under the lumped. Okay, so that means whenever we are having the networks in which RLC parameters are individually concentrated or lumped at discrete points in the circuit are going to be calling as lumped networks, and these networks can be identified definitely by representing a particular parameter. As example is filters. Okay, this is an correct answer. That is option A is the correct answer. Next question. The lines having RLC distributed along the circuit are called as. The lines having RLC distributed along the circuit are called as. The first one option is lumped, and second option is distributed, and the third option is parallel, and the fourth option is paired. So that means the lines having the RLC, that is resistance, inductance, capacitance, distributed along the circuit are called as. The first option is lumped, and the second option is distributed, and the third option is parallel, and the fourth option is paired. So which one is the correct? So please note this question. The lines having resistance, inductance, capacitance distributed along the circuit are called as. The first option is lumped, and the next option is distributed, and the third option is parallel, and the fourth option is paired. So which one is the correct? The answer is distributed. Okay, so whenever we are using the distributed lines, the primary parameters are going to be distributed around the circuit with each elemental length having its own values, and the concentration of the individual parameters is not possible. So an example is the transmission of power. Okay, that means in the distributed lines, the parameters which are going to be distributed along the circuit with each element length, okay, having its own value, and the concentration of individual parameters is not going to be possible. So that is why the answer is distributed. That means the lines having the RLC distributed along the circuit are going to be calling as distributed lines. Okay, so the second option is the correct answer. Next question. Which primary parameter is uniformly distributed along the length of the conductor? Which primary parameter is uniformly distributed along the length of the conductor? The first one is G, and second one is C, and third one is L, and the last one is R. So what is an primary parameter which is uniformly distributed along the length of the conductor? So please note this question. So which primary parameter is uniformly distributed along the length of the conductor means the first option is G, and second option is C, and third option is L, and the last option is R. So which one is the correct answer? That is D. The resistance is a primary parameter that is uniformly distributed along the length of the conductor, which will depends upon the cross section area and length of the conductor. So resistance is uniformly distributed along the length of the conductor. Okay, so that is a primary parameter which will be uniformly distributing along the length of the conductor. So that is resistance. Okay, so in this session I have covered so much of things, that are what is a transmission line, that means what is the introduction to the transmission line, and what are the types of transmission lines, and what is a capacitance and what is a inductance. Okay, in this session I have covered with the introduction to transmission lines, that is whenever we are using the why we are going to be using the transmission lines means in the field of electronics it is needed to guide the electrical energy from one point to another point. So one form of is nothing but an RF signal is the example of one form of electrical energy. So whenever it is going to be need to guide the RF signal from the transmitter to antenna, for that we need a guided media. So that guided media is going to be calling as transmission line, and this the transmission line which will be guiding the RF signals from the transmitter to antenna with least possible power loss, and the power loss will be depends upon the special physical and electrical characteristics of the transmission line. Okay, so what are the physical characteristics and what are the electrical characteristics I have told in this session, and what is a transmission line and what is the capacitance of a transmission line means whenever we are having some potential difference between the conductors, we are having is going to be get a charge in the same way as that of the parallel plates of a capacitor. So for that we have a capacitance between the two parallel conductors, depends upon the size and spacing between the conductors, that is the capacitance. Okay, so what is an inductance means in this transmission lines, we are having an long transmission lines, inductance is more effective than resistance. So whenever the current flows in the transmission lines interacts with the other parameter, that is inductance. Okay, so whenever the current flow within the conductor, the magnetic flux is going to be generated, that is magnetic flux is going to be set up. Okay, with the variation of current in the conductors, the number of lines of flux also changes, and there is an EMF induced in that. Okay, so that means variation of current in the conductors, the number of lines of flux are going to be changes, and an EMF is going to be induced in that. That is going to be calling as Faraday's laws. Okay, the induced EMF is represented by the parameter known as inductance. So that is an inductance of transmission line. So capacitance is nothing but the conductors will get charged in the same way as that of the parallel plates of capacitor. We are going to be calling as a capacitance. Okay, that means whenever we have two parallel plates or two parallel conductors, that will be having a capacitance parameter. That means which will depends upon the size and spacing between the conductors, and the loss are usually the capacitance is going to be neglected for the transmission lines which are less than the 80 kilometers long or less than the 20 miles of the long line. Okay, so that is the main important under the capacitance. And what is the resistance means? I have told that the resistance is going to be defined as the sum of resistance of both wires for unit length line. Okay, so which can be given as ohms per kilometer. So whenever we are having the resistance, we have a well familiar with the formula that rho L by A. That means the capacitance will be depends upon the cross sectional area and the length of the line and area of the cross sectional area and specific resistivity of the line. Okay, so these are the parameters which will be having some changes, and whenever it is having some changes, that will affect on the resistance. Okay, so in a single phase or two wire DC line, the total resistance calling as slope resistance is going to be equal to the double the resistance of either conductors. Okay, so in the case of three phase transmission line, the resistance per phase is going to be the resistance of one conductor. So that is the difference between the resistance of a single phase. At the same time, three phase transmission line, there is some change, means the resistance will be double of the resistance of either conductor in the single phase, but in the three phase the resistance is going to be the one conductor resistance. That is the line of whenever we are going to be using transmission lines, the resistance per phase is the resistance of one conductor only in the three phase. And what is the leakage current means? I have told that whenever we are having the transmission line, the air is going to be acting as a dielectric medium between the two conductors, and whenever the alternating voltage applies in the conductor, some current flows in the dielectric medium. Because of the dielectric medium as a air, and there is a imperfections in that, and some such current is going to be having in that, so such current is going to be calling as leakage current. So the leakage current which will be depends upon the atmosphere effects and also pollution like moisture and surface deposits, whatever it may be, they are the reasons comes under the atmospheric effects. Okay, that is going to be calling as leakage current. And I have told about the types of transmission lines, and in the transmission lines we are number of having, but primarily we are having the first type is parallel transmission line, and the next one is twisted pair transmission lines, and the third one is coaxial cable, and the fourth one is waveguides, and fifth one is fiber optic cables. Okay, so whenever we are using the traditional transmission lines which are going to be used with the parallel transmission line or a copper wire, okay, that will comes under the traditional, and whenever we are using the waveguides, it is going to be used with the these are these are the guided media which is used at high frequency signals. That means I have told that for traditional transmission lines at high frequency micro frequencies cannot be used. Special type of guided media can be used for high frequency signals. The special type is going to be calling as waveguides. So the waveguides are going to be used to transmit the microwave frequency signals from one point to the another point with less power loss. Okay, so in addition to the waveguides, different types of couplers and isolators are going to be used in the microwave circuits. Okay, so whenever we are having the transmission lines, which are having some electrical parameters. Okay, so based on that, the characteristics, the waveguides are going to be used, and the waveguides are going to be using at micro frequency ranges. Okay, so these are having with the waveguides, and whenever we are having the parallel transmission line, it can be calling as two wire open line. Okay, and this is the parallel wire type and is most often used for power lines, telephone lines. Okay, so that is going to be used. And in the twisted pair also we are having some advantages. It is mainly used for our LAN networks, and it is mainly used for transmitting the high frequencies also. But whenever we use the high frequencies, there is a problem with the twisted pairs, and that's the reason we are having number of reasons we can see in the next videos also. Okay, what are the types and what are the internal internal diagrams of the twisted pairs. Okay, so whenever we are having this, we can also have the number of sessions under the twisted pairs. Okay, and when comes under the coaxial cables, we can also call as coax. Okay, so whenever we use this, it is mainly used for our dish TVs, that is for having the cable TV connections. For distributing of the cable television signals, we are going to be using this. Okay, and mainly for our home connections also we can see with the coaxial cables. Okay, and comes under the waveguides. I have said that they are going to be used for transferring the electromagnetic energy which are at high frequency ranges. And in the waveguides we are having so much of types. They may be rectangular, circular, or elliptical in shape. Okay, so based on the shape it is not going to be changes, but based on the configuration we are going to be calling as rectangular, circular, and elliptical shape. Okay, so that's the reason. And the next one is fiber optic cable. We can well known about the fiber optic cable. Why? Because whenever we have a speed, whenever we need to increase the speed of the signal, we are going to be using the fiber optics. Why? Because which comes under the electromagnetic energy in the form of light. That means we are transmitting the energy in the form of light. So for that we are going to be using the fiber optic cable. Why? Because the light speed is going to be higher when compared with a normal electromagnetic energy flowing. Okay, so that is the reason for using the fiber optic cables. And not only with that, under the transmission lines, most probably we are comes under the fiber optic cable only. Why? Because the speed is going to be high and the loss is also going to be very less when compared with other transmission lines. Okay, this is about this session, and we have known with the what is a transmission line and what is the use of transmission line, why we are going to be use this transmission lines, and what are the physical and electrical characteristics that will be depends upon the power loss of our transmission line. And whenever we are using the traditional transmission line, what is the main use of that and why we are not going to use that in our micro frequency ranges. We are going to be having a special type of guided medias such as waveguides. Like this we are having we have seen with this in the introduction part, and at the same time what is a capacitance of transmission line, and what is an inductance of transmission line, and what is a resistance of transmission line, and what is a leakage current of transmission line, and what are the types of transmission lines. So we have well known of this. Okay, so this is about our summary of this session, and I have seen with the quiz also. Okay, thank you.